Hello and welcome. Today, in the 9th week of first lecture, let us discuss about climate technology, and particularly we will try to discuss about the concepts and frameworks. So, to do this, let us take a look at the concepts what we are going to cover. So, the concepts what will be covered are, we will define the climate technology as per the IPCC assessment report 6. That distinguishes mitigation as far as the greenhouse gas reduction is concerned from adaptation that enables a kind of resilience building. The second concept what we will be covering are to identify the critical enablers. Who are the factors that enables in terms of the climate technology? So, we understand now that the technology innovation and international cooperation for accelerating climate action and low carbon transitions are the technologies that actually helps in terms of identifying the critical enablers. And then moving on, as far as the other enablers are concerned, international cooperation for accelerating climate action and low carbon transitions. Third, we will discuss about the various mitigation technology. We will analyze them, including the renewables, particularly solar, wind, energy storage, the BESS and the CCUS, the carbon capture, utilization, storage, green hydrogen, and the EVs, the electric vehicles, and all those things. Then we will discuss about evaluating the adaptation technology such as the EWS. At various points we have already put the weather or emergency kind of warning systems, or you say the early warning systems, EWS, the precision agriculture, climate resilient infrastructure, and nature based solutions for vulnerability reductions. Then we will go on to address various some kind of case studies as far as the climate technology is concerned. So, first, in terms of defining the climate technology, look at this. We are discriminating between mitigation and adaptation technology. So, climate technology includes the technologies that reduce the greenhouse emissions. This component, the reduction in greenhouse gas component, we put it under mitigation, and to increase the resilience to climate impacts, we put under the adaptation framework. So, as far as the mitigation technology is concerned, so what are the technologies we have to reduce the greenhouse gas emissions? That could include the solar photovoltaic cells and wind energy, electric vehicles and heat pumps, the green hydrogen, carbon capture and storage technologies. Now, coming to the adaptation technology that build, as we just discussed, that build the climate resilience, such as climate smart agriculture, or we say the climate resilient agriculture, the various water management technologies such as rainwater harvesting, desalination, coastal protection such as mangroves and sea walls, and also various early warning systems such as EWS. Now, moving on to the other technologies that enables this or helps in realizing this are the various cross-cutting technologies such as artificial intelligence, large data analytics, the digital twin systems, precision monitoring. So, all these technologies, they enhance both mitigation and adaptation. And coming to the next one is with respect to the CDR, the carbon dioxide removal technologies, that includes direct air capture, that means DAC, bioenergy with CCS, BECCS, and enhanced weathering, afforestation, and all these things. So, these are the definitions as far as the climate technology are concerned: mitigation, adaptation, cross-cutting technology, and the CDR, that includes the climate the carbon dioxide removal technologies, including DSC, BECCs. So now, if we put them under three different subheadings, so in terms of climate technology that helps us or gives us the tools to combat climate change. So this can be put or discussed under three broadly: mitigation, adaptation, and sub technology, as you can see from the depiction. And in terms of the mitigation, renewable energy technologies, low carbon transport, all these fall under the mitigation technologies using solar powers, wind energy, and EVs. As far as the adaptation is concerned, as we have also previously discussed, this needs to we need to adapt to various adverse conditions or adverse effects as far as the climate change is concerned. So coming to that, we have various drought resistant crops, the early warning systems, EWS, sea walls, and coastal defense. So these all help us in terms of providing adaptation to various adverse conditions that arises because of climate change. And also, let's move on to the other one. The third one is the sub technologies. So this includes various practices, knowledge, and training. So energy efficient practices. So if we adapt to this kind of behavioral changes by developing our skill set or through various policy framework, then we do better, including the training and capacity building. So according to the European Union taxonomy, climate technology refers to innovative products, services, and technologies that address at least one of the 6 objectives for sustainable activities. First, climate change mitigation. Second, adaptation. Third, we put, as far as the net zero insights are concerned, third is we put it as pollution prevention and control. And fourth is transition to a circular economy. Fifth can be protection and restoration of biodiversity and ecosystems. Sixth is sustainable use and protection of water and marine resources. Then let us see what are the critical factors that enables this climate action or that accelerates the climate action. So let us see the enabling factors. So we can put them under 3. The finance, definitely we have been discussing. Second is the technology, particularly the innovative technologies. Third is the IC, the international cooperation. So finance, technology, international cooperation are the key drivers for achieving the global climate goals and enabling climate resilient development. So finance, the role it plays is it is essential for very low carbon transition and climate resilience. We need money, we need funding to come out with or to move from high carbon intensive to a low carbon intensive. So that means this transition and also climate resilience. As far as the Paris Agreement goal is concerned, it aligns financial flows with low emission development. Third is scale of need. So it mitigates investment as far as the need of as far as the scale is concerned. The mitigation investment must increase 3 to 6 times whatever we are doing at the current time. So as far as this was also discussed in the Paris Agreement, which says that it aligns financial flows with low emission development, and the changes that this finance, it drives the systematic change in terms of energy and infrastructure. So the main point is finance or the funding is required for transition from a high carbon intensive to a low carbon intensive energy system. Coming to the second enabling factor is the technology, or you say innovative technology. It enables system transition towards low carbon development, such as examples are photo solar photovoltaic cells, the LEDs. You can see one depiction on the upper right hand side. We all are using these as light emitting diodes, or we very well know it as LEDs. And then the EVs, the electric vehicles we have been used, and also the technology what is also practiced are in terms of carbon capture, utilization and storage. Technology diffusion and commercialization are also very crucial. And in terms of technology, it requires strong innovation system and institutional support. Coming to the international cooperation. So first is finance, second is the technology. Whatever technology has been developed, now we need international cooperation. So international cooperation accelerates climate investment and adaptation efforts. It supports the vulnerable countries facing high climate risks. The international cooperation also facilitates technology transfer between or among countries, knowledge sharing between and among countries, and also capacity building. And this ICR international cooperation, it ensures equitable climate finance and global collaboration. So these are the three critical enablers as far as the climate action is concerned. So the second one, including the first and third, is very important. Second one, we are talking about the technology, but to facilitate this, to enable this, we need fund flow, that is finance, and also international cooperation, because the knowledge support system, investment system, that also translates between countries or among countries through international cooperation. Coming to the mitigation technologies. Mitigation technologies aim to reduce or prevent the emission of greenhouse gases into atmosphere, or to remove the greenhouse gases that have already been emitted. They operate across all major emitting sectors. So as far as the renewable energy technology is concerned, let us talk about the photovoltaic cells, the PVs. As we know, PVs, they convert the sunlight or solar light into electricity using semiconductor cells. These are very modern modules. They reach up to 22% efficiency level, and the photovoltaic cells, as we know, these are used in terms of utility for utility scaling plants over the rooftops, and also in terms of agrovoltaic systems. Coming to the second in terms of the renewable energy technology is the wind energy. So the wind turbines, they convert kinetic energy of wind into electricity here. So India is the fourth largest wind energy market. Global capacity of 1000 gigawatt by 2023, and India has committed in terms of 45% gigawatt on onshore wind energy is harvested. The third one, which is taking prominence these days, is the green hydrogen. This is produced by electrolysis using the renewable electricity. It is important for steel, fertilizers, heavy transport, and long duration energy storage. So on the upper right hand side, we have an example or a photographic depiction of a photovoltaic cell and the different components within. Moving on, as far as the energy transition is concerned, renewable energy storage, as we discussed, the solar photovoltaic cells and wind are the fast growing power sources, and they help in terms of reducing the cost and higher energy efficiency. So that means we put it under LCOE, levelized cost of electricity. And as far as the storage or energy storage system is concerned, in terms of mitigation technologies, it balances variable energy, renewable energies, particularly in terms of lithium-ion batteries, flow batteries, pumped hydro, and compressed air. So all these technologies help in terms of storing a lot of these renewable energies. Coming to the grids, in terms of decarbonizing grids, so smart grids and artificial intelligence, they improve the energy management and enable higher renewable penetration. So in that way, India is the third largest renewable energy market. And as far as the installed capacity by 2023 is concerned, solar 72 gigawatts, wind 43 gigawatts, and hydro 46. So have a look at the upper right hand pie diagram. By 2015 and comparison to the March 2015 comparison to March 2024 over a time scale of 9 to 10 years, and you see the amount of small scale hydropower contribution have decreased, whereas in terms of the contribution from the solar power has increased. Look at the yellow region. This has increased from 9.97 to 56%. So look at the magenta portion that talks about the biopower, and the other one is the wind. So we have increased between over last decade, that means 2015 to 2024, in terms of the energy transition as far as non-renewable to renewable energy is concerned. So targets and trends. As far as the national solar mission target is concerned, 280 gigawatt solar power, solar energy by 2030 by end of this decade. Solar cost will come down by 90%, has come down by 90% since 2010, and the total solar, wind, bioenergy and small hydro are together giving about 143.6 gigawatts of energy or power. Let us have a look at the National Solar Mission NSM as far as India is concerned. So it is a phase journey to 100 gigawatts. You can see in terms of the phase 1 building foundation 2010 to 2013 in terms of 1100 megawatt. Coming to phase 2 2013 to 2017, it is 10,000, and now moving on to 2025 phase 3, that means to achieve the global leadership. So we have a what you say steady increase in terms of the production from as far as the energy is concerned from this in terms of phase 1, 2 and 3. And the key achievements, so major reduction in solar tariffs and generation costs. So initially it was very high, now it has come down from 17.91 rupees per kilowatt hour in terms of less than 5 rupees per kilowatt hour, and it is still going to decrease. So that means this mission is if this mission is accomplished, then 105 gigawatt installed in terms of India surpass its ambitions as far as 100 gigawatt goal by March 2025. So according to this NSM, India has already surpassed its target in terms of crossing what is the committed is 100 gigawatts. It has already crossed 105 or accomplished 105 by 2025. So solar power expanded also in rural in terms of rural area, electrification and irrigation. As far as the policy impact is concerned, this NSM contributed to India's Paris Agreement target. So India is also signatory to the Paris Agreement target 2015. So it contributed as well the commitment. 40% of the non-fossil electricity capacity by 2030, which has well been achieved, and boosted the rooftop solar and rural energy access. Moving on in terms of mitigation technologies, as far as the Bhadla Solar Park at Rajasthan is concerned, so you can see a blueprint for the desert solar power. This is one of the world's largest solar park developed by integration of NTPC, National Thermal Power Corporation, REIL, Renewable Energy India Limited, and various private developers covering 57 square kilometer of area. So you can see by numbers it is a massive scale, and you can see it is the world's largest solar park is in India. So 2245 megawatt generation capacity, So it makes India's largest solar installation covering 14,000 acres. And as 4 million tons of greenhouse gases emission reduced annually because of this 4 million tons of greenhouse gas emission is reduced annually. So it's a major contribution as far as India's commitment to climate goal and energy transition is concerned. Now coming to the third point, India has achieved the record low energy tariff. So that means it proved utility, but utility scale solar is as affordable as conventional grid power. So if you go for a larger installation, then it becomes cheaper. So the challenge is a holistic desert environment. So when it is put in a desert area in Rajasthan at Bhadla, so it faces extreme temperature of 48 degrees centigrade. So and also there are frequent sandstorms and severe water scarcity. As far as the solution is concerned, we need a kind of robotic cleaning, waterless robotic cleaning. Over 2,000 automated robots sweep the dust from the panels nightly without using water. So there is no water there, and you have the desert storm. So about 2,000 automated robots are engaged to clean this in every night on the night base, once in a day they clean this. So you don't need water, you don't need a lot of manpower. It is automation using robots or other AI technologies. Now coming to the solutions in terms of advanced panels to maximize the yield, we need advanced very high yield panels in order to maximize the yield. So uses trackers to follow the sun and bifacial modules to capture the reflected light. So you see it can face or it can move, the solar panels can move according to the sun movement, so that it can capture maximum of the solar light. So this is the key highlight in terms of innovation: robotic cleaning, dust mitigation, and high resistant panels. Coming to the CCS and nature-based solution, friends, we have already discussed about the nature-based solution in our last week discussion. Now move on to the carbon capture utilization and storage technologies in terms of decarbonization and carbon removal. So carbon capture, utilization and storage, it captures. So through this technology we capture the carbon dioxide from large industrial sources, or you say the large point sources such as power plants and cement and steel industries. Carbon dioxide is compressed and then stored underground. That means we take them or withdraw them from the atmosphere and put them under the geological storage, and this is used to produce or sometimes also we produce synthetic fuels or chemicals or the concretes, and it is essential for hard to abate the sector. So this is well practiced. And coming to DSC, directly we capture the carbon dioxide and many other greenhouse gases from the air, and also CDR carbon dioxide removal. So DSC captures directly from the atmosphere near to point sources or around the city areas. CDR also removes the carbon dioxide to achieve the negative emissions. So these are important technologies for long-term climate stabilization. But as far as the maturity level is concerned, it is still between 5 to 7, but the cost is very high. The cost is higher than the long-term target, 1,000 tons per carbon dioxide, $100 per tons of carbon dioxide removed. So the cost is high. So we need to work out there. Coming to the adaptation technology in terms of information and monitoring, let us look at the adaptation technologies. They help the societies and ecosystem to adjust to climate impacts such as heat waves, floods, droughts, sea level rise. All this we are receiving these days increasingly as extreme weather events. So why adaptation is critical for India? Because India has very high population base, 600 million people depend on climate sensitive agriculture. 300 million people in coastal regions, they are vulnerable to cyclone and sea level rise. 500 million depend on Himalayan glacier fed rivers, and increasingly we have been receiving heat waves, floods, droughts and sea level rise. So that is why the adaptation is very critical for India. So let us see what are the key adaptation technology. Few of them we have already discussed before, but as far as the technology is concerned, we have the early warning systems, EWS. So climate models, satellites and IoT sensors, they provide the early alert systems for as far as the disaster is concerned. So if we get these days, we have been receiving this in terms of tsunami, in terms of cyclones, in terms of the lightning and many other, in terms of heat waves also. The AI and big data used for risk mapping, identifying vulnerable population and disaster planning. Coming to smart water management, sensors and localized weather data improve irrigation efficiency. Desalination and water recycling enhance water availability in drought-prone regions. Now, let us see the two paths in order to achieve the climate resilience adaptation technology between the hard and the soft. So, the soft we are particularly putting in terms of the nature-based solution, and hard engineering, particularly the structural approach. So, look at this on the left-hand side. We have building. We have a lot of physical barriers in terms of building. We are building physical barriers. Employ man-made structures that such as sea wells, and we live and lives for the robust physical defense from the cyclone or sea level rise. Coming to the next is the protecting critical infrastructure. At Washington DC, facility built seawall to shield against the anticipated river floods. Coming to the third one is the risk of maladaptation. Fixed solutions can fail if climate extremes exceed their original design limits. Now, on the right hand side, as far as the NBS, nature based solution, or the soft engineering is concerned, we already have discussed it in the previous weeks, as I mentioned, working with nature. Now, whatever way you feel like, put as much as what you say, as much as green or vegetation along and across and in between the living space in terms of rooftop building. So leverage ecosystem function to provide sustainable and eco-friendly adaptation benefits. In terms of the what you say, the porous kind of areas, structures and systems along and across the city space, and also the co-benefits when we try to retain a lot of what you say wetlands or the low-lying areas. That gives a kind of buffer to in terms of cooling off, in terms of the flood or the fast flood and all these things around and across the habitations or our landscape. So this soft engineering or natural approach, they fall under the nature-based solution. Now, as per the third approach, that is enabled by digital technologies, this as we already mentioned, in terms of the early warning systems, we are using satellite based, AI based and many other things so as to effectively move to a kind of very efficient early warning systems. And also forecasting or you say you alert system based on the AI powered or AI based models that improve the climate predictions. So friends, these are the various references we have used in terms of IPCC reports we have looked at, in terms of specialized reports for Bhadla solar park. We also looked at the BECC report in terms of CEW report in terms of India Climate Vulnerability 2023. We also looked at the IEA report as far as the world energy is concerned. We also looked at the UNEP Adaptation Gap report and India Energy Outlook and the Renewables reports. So, to conclude, We discussed about the mitigation and adaptation technologies that are essential to tackle the climate change and build resilience. The three key enablers: finance, technology innovation, and international cooperation. They are the three key enablers in order to address the climate action. But the important one is the technology innovation that we are discussing this week. To enable this, the finance and the international cooperation is a must. Coming to mitigation solution, renewable energy in terms of solar, energy storage, carbon capture, green hydrogen, and electric vehicles, EVs, all of them are in place. As far as adaptation, the early warning, climate smart agriculture, nature-based solution, as we discussed. So, India is leading. India's leadership is well proved because it has already achieved the more than 100 gigawatt solar power what was committed to be achieved by 2025. So it has crossed and achieved 105 gigawatts of solar power. And coming to deep decarbonization, it requires transformation power, industry, and transport. Thank you very much.